we're going to learn a very, very interesting probability distribution. I just think it's very interesting. It's called a binomial probability distribution. Distribution. Okay. Binomial probability distribution. And remember, what is a probability distribution? There are three requirements. Number one, the random variable x is numerical, and a p of x shows the probability of that x. And second requirement is all the probabilities add up to 1. And the third one is all the probabilities between every single value between 1 and 0, inclusive, right? Cannot be negative, cannot be more than 1. For binomial probability, there are 4 requirements. There are 4 requirements for probability distribution, for binomial probability distribution. Okay, number 1, there is a fixed number of, we call this as trials. Okay. The procedure has a fixed number of trials. We use n to show that. That means you're going to do something n times. All right, and each trial is just a single observation. So we're going to use n. And the second one, and each trial, they're independent, which means whatever happened to the first trial has nothing to do with the second trial. So each one is independent. The third one, each trial that has only 2 possible outcomes usually we call them success or failure. Okay, so only 2. That's what this bi coming from. Binomial. This bi means there are 2 possible outcomes. And the last one, the probability of success is the same for each. Okay, so that's the 4 requirements for the binomial probability distribution. And this one, we call this the probability of success. We use PS. Okay, and the other one, the fail, will be PF, right? Isn't it? Probability of success, probability of failure, and the probability of success plus the probability of a failure equals 1. Or you can use a P to show this, and you use Q to show that. So P plus Q is 1. That's another way to show that. So we have N, and we have independent 2 probabilities, and then we have success and the failure. We use the probability P and Q to show that. All right, now what is a random variable? The random variable x is the number, let me just write that, is the number of successes in n trials. Okay. En trials. All right. So let me see. We have 4 letters. Actually, there are 3. We have N, we have X, we have P. And of course, we have a Q, but Q doesn't really matter because Q will be just 1 minus P. Okay, so let me talk about this. Let me give you one example, okay? Example 1. Example 1, we talk about the whole population, when an adult smartphone owner is randomly selected with replacement What does with replacement mean? That means you randomly select a person who has a smartphone, and then you ask him, do you have cash? Do you carry cash with you? This person's answer will be yes or no. Okay, so what we know is, so far we know the probability of success or cash, let me see, the cashless, which means no cash, would be 0 or 5. So 5% of the chance that this person has no cash because he has a smartphone, he just used that. I believe right now in many countries this chance is much higher, but so far we just assume that, okay, this is a survey in US. All right, now the probability of cashless is 0.05. So we talk about the probability of the whole universe. And then you ask some people. Let's say how many people you ask. You ask n people. All right? You ask 10 people. Everyone will give you an answer, either yes or no. And the answer of cashless should have the same probability. I'm asking you, what is the probability of 2? Which means for each person you ask, the chance that his answer is cashless is 5%. And you ask 10 people, and what is the chance that exactly 2 persons will answer cashless? All right? So in this case, we have n is 10. We have x equals 2. This means x equals 2, right? Exactly 2 people. And here we have the cashless. For each single one is 0.05. And with replacement means after you ask a certain person, you're going to put him back to the population, and then you mix everybody, and then you randomly ask the next person. So that means they're independent. Now let's look at this 4 requirements to see whether we should use a binomial probability distribution. Do we have a fixed number of trials? It's not unlimited, okay? It's n, so we only ask 10 people. And then is trial independent? The answer is yes, because replacement. And then, are there only 2 possible outcomes? What are the two possible outcomes? Yes or no, yes or no, right? In our case, the success is cashless, and is with cash. And the probability of is the same for each trial. Yeah. What is that? 5%, right? So 0.05. This is a very good example of binomial distribution. So after you identified NPX, I will a formula. The formula is this: P of x equals to a certain value, right? Which is n factorial over n minus x factorial x factorial p to the x and a q n minus x. This is the letter p here. Okay, 4 x equals 0 and 1 and 2 and 3 and all the way to n. Okay, so this is the x value, and here's the probability of it. Then you can have x, p of x, here will be 0 and a 1 and a 2 and all the way to n, and then you have the probabilities. That's a binomial probability distribution. We have the formula. If I give you n and the x and the p, of course you know what is q, because q is just 1 minus p. Success, failure, right? Okay, complementary events. Therefore, we can find the probability for whatever x value. Now, we compare that with this. We compare that with this one. We have the formula, and then we are going to find what is a p of 2. So in this case, we have n is 10. We have a p is 0.0. Of course, q will be 0.95, which because that's 1 minus that. And then let's do it. So p of 2 equals n is 10 factorial over 10 minus 2 factorial. We just plug in 2 factorial. And p 0.05 to the power of x is 2. And the q, which is 0.95 to the power of 10 minus 2. Okay, that actually equals this. Okay. Does this look familiar? Yes, that's a combination, right? Combination, we choose 2 out of 10. That's how many different ways that you're gonna have 2 out of 10. All right, now what is this? That is the probability that the 2 person are cashless, and the probability that 8 person are with cash, right? So 8 people with cash, 2 people with no cash, and that is the you multiply because they're independent. You multiply together, and how many different ways that you can work. You can do this out of this 10 people. Could be the first one cashless, the second one cashless. If the number 1, number 2 are cashless, then that's the probability here, right? And what happened if the number 1 and number 3 are cashless? The chance is also like that. So what is how many different ways that 2 person in this out of 10 are cashless? And that is this. That's how many different ways that you're going to range this 2 person up in this group of 10 people. You see that? That's a very interesting explanation, and also you can see that if you don't understand it, that is fine, but you can just go ahead and calculate it. So I want you to know how to calculate this by your calculator, and this one is 10 factorial. You can plug in 10 factorial in your calculator, or you can write 10 times 9 times 8. If you want, you can keep writing, but you can just stop here, put 8 factorial, because down here you have 8 factorial, and then 2 times 1, that's the 2 factorial. Here's multiplication, and here's a 0.05 square, and here's a 0.95 to the 8th, and this canceled out. So you can use the calculator. Let me see. Okay, I'm gonna use my calculator to show you how to do that. Okay, to the left. So I start from this one. Okay, 0.95 to the 8th power, which is here. You see this x to the y here? So you click that, and then 8. All right, and then you multiply by 0.05, and this one is easy because you have the square. All right, and then you're going to multiply by, and here is a 10 times 9 over 2. Well, this one I think you can just do it by heart, because 10 times 9 is 90, divided by 2 is 45. So I just go ahead, equal to, so that answer is 0.07. I like to keep 4 decimal places for that, if possible. So 4, 6, because the next digit is a 3, so I don't keep that. All right, so that's my probability distribution, the P of 2. So I get a P of 2 is this. That means if you ask a 10 person, do you carry cash with you? 10 person with a smartphone, do you carry cash with you? And the probability that exactly 2 of them are cashless is this. Can you find a P of 0? Can you find a P of 1 and all the way to P of 10? Yes, just plug that into this beautiful formula, right? So you can find that. So far we know P of 2 here in our situation is 0.0746. So that is the binomial probability distribution. Okay, now you might want to ask, what happened when n is 20? If I want to get the probability distribution like this, do I have to use this formula like a 20, basically 21 times, right? Because from 0 and 1 and all the way to 20. I'm sorry, yes, that's one way to do it. And of course you don't want to use this, right? And there's several ways. One is you can go to our book. There's usually there's some table for that. If your book has a table, in my book, in the book that we're using, it's on page 597. It's in appendix A. You can do that. Or you can do this. You can go to the internet, because right now everybody uses internet. So you go to internet, you're going to Google binomial probability distribution calculator. If you Google this, I'm pretty sure there's going to be like so many different websites that it just asks you to enter this. Just ask you to enter N, P, X, and sometimes they didn't even ask for X. They just give you the probability here, because the only thing you need is N and P. And they give you a lot of things. For example, there's one website called a StatTrack, because I think I saw that. I think it's very nice. There must be some, there's a lot of others. I think there is one called a Statistics Helper or something like that. There are tons of them. And it's funny because they ask you to enter N and P, and sometimes they ask you to enter X. But after you enter X, they give you this. They give you what is the probability of X. Okay, and they give you, let's see, in our situation we have N is 10, and we have P is 0.05, and they ask you to enter X, so you enter 2. And then they give you what is the probability that X equals 2, and what is the probability that X is less than 2, means less than 2%, right? And what is the probability that X is less than or equal to 2, which they just add these two probabilities together. And what is the probability that X is greater than 2, and what is the probability that X is greater than or equal than 2. It's interesting. A lot of websites will give you, after you enter the N and the P and X, they give you all those 5 probabilities. It's very, very helpful. Okay. So that's how do you find it. That's how do you use the online tool or the table to find the probability distribution. And for this table, usually when you have the table, they only, because you cannot list all the possible P's, right? The P could be any number. So usually when you go with the table, at the back of the book, they only give you certain probabilities, like 1%, 5%, 10%, some like a commonly used percent. And then for N, they cannot give you too big, maybe just 2 or 3 or 4 or 5, maybe up to 10, because there's a limit. Okay, now we work on the next example, and then 2. Okay, based on a Gallup poll, 5% of U.S. adult are vegetarians. So 5%. So the probability of vegetarian is 0.05. That's what we know, right? Okay, if we randomly select 5 adults, find the probability that exactly 2 out of the 5 are vegetarians. So N equals 5, P equals 0.05, and X equals 2. I ask you, what is the probability that X equals 2? All right, now, can you stop and then go to either the table or online, whatever method, you go ahead and then go open a Google, open your browser and go to Google and search it and then plug that in and to see whether you can get the answer. Of course, if not, then you can just use the formula. But right now I want to use different thing. I want to use the tool. All right, so I'm going to put that on. You pause it, go there and find it, come back later, and check with my answer. I got a 0.021. Okay, so if we have 5 people together, we go out have lunch, and we found that, oh, we got exactly 2 person, they're vegetarian. You know what's the chance? The chance is tiny. Well, it's very small. It's only 2.1%. It's very, very small. All right, now let me ask you another question. What is the probability that there are fewer than 3? So what is the probability that X is fewer than 3? That would be the probability of a 0 or 1 or 2, isn't it? Okay, so some of the calculator give you the probability that X is less than or equal than 2. You can just use that answer, okay, which is what? 0.999. So fewer than 2. So it could be 0, could be 1, could be 2. Almost, well, it's 99.9%, okay? You get a fewer than 2. Then what do you think about the probability of 3, probability of 4, and the probability of 5? What is the probability that 3 or more are vegetarian? That would be just 1 minus that, which is 0.001. It's 0.1%. So if you just randomly you get 5 people together and then you go out have lunch and you find out, oh, wow, we got 3 or 4 or 5 of them are vegetarian, the chance is tiny. Isn't it interesting? Okay. All right, now every time when we talk about the probability distribution, we talk about a mean and a standard deviation, right? Now for binomial probability distribution, mu will be just n times p, and the standard deviation will be just the square root of n times p times q. Okay? Vegetarian thing. So we have n equals 5 people, and the probability equals 0.05. What is mu? Mu is n times p. That means averagely 5 times 0.05. Averagely, there are 0.25 person a vegetarian. So what is the standard deviation, which is the square root of npq? So that will be the square root of n is 10 times 0.05 times 0.95, and you take a square root, calculator. Here, the calculator. So we go 10 times 0.05 times 0.95 equal. That's inside, and then we take the square root of it. I got a 0.6892. Just one more. Okay, so we get a mean, we get a standard deviation. Let's see, what is that 2 standard deviations away? So mu plus 2 sigma, mu minus 2 sigma. So that will be 0.25 minus 2 times 0.6892, and 0.25 plus 2 times 0.6892. And let's see. So 2 times 0.6892, and then I'm going to plus 0.25 to it. So I got a 1.6284. Okay, and the other side, I get a 0.6892 times 2, and then 0.25. So I get a let's see, I have a negative 1.3 something. Oh, I got a negative 1.1284. All right, so for any, if you have 5 people go out have lunch together, the chance, as long as you get a more than 1.62 or less than negative, of course there's no way you're not going to get any negative number of people who are vegetarian. But if you have a more than 1.6, which means you get a 2 or 3 or 4 or 5 of them are vegetarian, even 2 is considered as a significantly high number. That's how you work with this. Once you have the mean and standard deviation, you can identify if this number is significantly high or significantly low. All right, now, and the last example we're going to do is this. All right, now we, for the, there's, here, example 3. Okay, for all these 460 NFL games, okay, that's between 1974 and 2011. So there's so many games were decided in overtime. These games decided in overtime, and the 252 of them were won by that won the overtime coin toss. One coin toss, because that means they like it. Okay. All right. So 460 NFL football games decided in overtime. 252 of them were won by the team that won the overtime coin toss. What do you think? Is this number significantly high? If this number compared to the okay, say that again. Is the result of 252 wins in the 460 games equivalent to random chance, or is this 252 wins significantly high? If it is significantly high, then that means it's not equivalent to a random chance, right? So we assume that the P of winning is 1/2. All right, so we have an N, it's a 460. We have a P, it's 0.5, and then we have our X is 252. We want to know if this is significantly high or not. In order to do that, we need to get a mean, we need to get a standard deviation, and then we need to get a mean plus or minus 2 standard deviations. So by formula, just write it here. Mu is NP, sigma is the square root of NPQ. Okay? So the mu will be 460 times 0.5, which is half. That's 230. So averagely should be 230, but our number is 252. We want to know whether it's significantly high or not. So this one is 460 times 0.5 times Q will be just 1 minus P, so it's also 0.5, and I'm using the calculator to find it's a 10.7. If it's a 10.7, let's do mu. I don't care because I want to know whether this is significantly high, so I only do mu plus 2 sigma, which is 230 plus 2 times 10.7, right? Mean plus 2 standard deviation. So that is 20 and 21.4, so it's 251.4. 251.4. And what do you have? You have 252, which is greater than, higher, or is outside your 2 standard deviation above the mean. So it is 252 is significantly high. Okay? All right. So that means the result of a 252 wins is significantly high because it's greater than 251.4 games found here. It is significantly high. That's your answer. All right, so everything we need to know about a binomial so far is here. So you can start working on the homework.